Welcome to The Explainer. Today, we're unpacking something truly phenomenal. We are looking at the absolute foundation of modern computing, the C programming language. Whether you're coding every single day or you just want to understand the invisible architecture running our digital world, you are definitely in the right place. We're going to break down exactly what C is, why it was created, and why, decades later, it remains a total cornerstone of the tech we use every single day. I'm super excited to guide you through this, so let's get right into it. Okay, so what does a gigantic, room-sized 1972 mainframe computer have in common with the sleek, modern smartphone sitting in your pocket right now? Sounds like a trick question, right? Obviously, the hardware has completely transformed. Screens, batteries, processors, they're virtually unrecognizable from 50 years ago. But the software DNA, the underlying logic that actually makes the hardware function, that is where they share a huge connection. And it's all thanks to the incredible, long-lasting legacy of the language we're exploring today. Okay, let's dive into this. We'll start with the birth of C, then we'll check out its core features and mechanics. After that, we'll hit its real-world applications, explore why it's the foundational language of programming, and finally, we'll wrap up with the ultimate definition. Let's kick things off with Section 1, the birth of C, and its 1970s origins. It's honestly pretty wild to think about the timeline of this language. Back in 1972, this brilliant computer scientist, Dennis Ritchie, was working at Bell Labs, which was basically the epicenter of tech innovation at the time. He needed a very specific tool, a language to help him develop the Unix operating system. So he built C. He didn't build it expecting it to take over the world. He literally just wanted to solve a specific problem in the early 70s. Yet, fast forward to the present day, and it remains one of the most widely used programming languages on the planet. A language built by one guy over 50 years ago for one operating system ended up conquering the entire computing world. So how exactly did it survive this long? Let's move to Section 2, core features and mechanics. Let's look under the hood. Let's rapid fire through the actual anatomy of C here, because this is where the magic really happens. First off, it's incredibly simple and efficient, which leads directly to the second point, fast execution. When you need a program to just fly without bogging down the system, C is absolutely your go-to. It's also portable, meaning it's not locked down to one specific type of machine. Add in the fact that it supports structured programming, so you can break massive complex code down into logical, manageable blocks, and that it's packed with a rich set of built-in operators and library functions. You can totally see why developers immediately fell in love with it. It was the perfect toolkit, light, fast, and super adaptable. Now, what's really interesting about this slide is the duality you get with C. On one hand, you have high-level portability. You can write your program on one computer and run it on a totally different one with basically zero changes. That broad accessibility was a game changer. But on the other hand, it gives you granular, low-level access. It actually lets developers interact directly with the computer's physical memory using these things called pointers. So you get the broad reach of a high-level language combined with the incredibly precise, gritty control of a low-level language. It's kind of like having a universal remote that also lets you easily rewire the television circuitry if you want to. So let's see how this all translates into execution with Section 3, Real-World Applications, or C in the Wild. It is actually staggering how deeply embedded C is in our everyday lives. Take operating systems. Unix kicked things off, sure, but huge parts of modern operating systems are still written in C today. And embedded systems? This is where it gets really fun. The microcontrollers in your smartwatch, your car's anti-lock brakes, or, yes, even that unnecessarily smart fridge in your kitchen, they're highly likely relying on C because of that lightning speed and low memory usage we just talked about. Then you've got system software, like the device drivers making your computer talk to your printer, or compilers that translate other coding languages. And finally, database systems. The massive core infrastructures holding all the world's data together. Literally all of them owe their lives to this 1970s tech. Which brings us nicely to Section 4, the programming foundation, and why C is basically the Latin of tech. Beyond just where it lives in the real world, let's look at why programmers structurally still choose it. The advantages of C include its crazy high performance, but it's also surprisingly easy to learn once you get the basics down, offering a really clean syntax. A massive advantage here is reusable code through functions. Instead of writing the exact same 50 lines of code over and over again, you just write it once as a function and call it whenever you need it. And because it's been around for so long, it's universally supported by compilers on virtually any platform you can think of. This right here brilliantly illustrates that Latin of tech analogy. C literally forms the foundational syntax for modern languages like C++, Java, and C#. Think about it like how the ancient language of Latin forms the root of modern Romance languages like Spanish and French. C provides the syntax, the structure, and the core concepts for the programming languages that came after it. If you actually take the time to learn C, picking up C++ or Java becomes immensely easier because you already understand the underlying grammar of modern computing. Its age isn't a weakness, it's absolutely a superpower. All right, we are arriving at our final stop, Section 5, the ultimate definition, or as I like to call it, the exam answer. If you're taking notes for a test, write this down, because this is the perfect synthesis of everything we've covered today. C is a general-purpose procedural programming language developed by Dennis Ritchie in 1972 at Bell Labs. It is used for system programming, application development, and embedded systems because of its speed, efficiency, and portability. Boom. That single sentence nails the who, the when, the where, the what, and most importantly, the why. It beautifully ties the history to the mechanics and the mechanics to the real-world applications. And that leaves us with this final, really fascinating thought. C has survived and honestly thrived for over half a century in an industry that usually reinvents itself every 6 months. I mean, new languages drop every single year with flashy features and AI integrations. But considering how deeply woven C is into the very hardware and operating systems of our entire world, will anything ever truly replace the foundation of modern computing? It's a massive question for the next generation of computer scientists to figure out. Thank you so much for joining me on this explainer. Keep learning, keep exploring, and I'll catch you next time.